live. So, welcome everyone at another Hubleto Dev Academy. Today we are on the lesson number 8. Welcome everyone. This is our welcome screen, but we are moving forward fast and furious. Hello everyone, we are getting ready. As usual, this session will be recorded, so if you have missed something or you are not able to attend the whole meeting, feel free to check the recording on our YouTube channel. And I will be your moderator, your host. So I will be checking regularly our live chat for new info, new questions, some remarks. So feel free to say hi in the chat or write some cool fact or maybe even cool book you have read recently. So we can get some new suggestions for us. So my name is Marcel, but I'm not the only one here. With me, there are my two great colleagues, Eric and Richard, and we will be soon hearing from them in a moment. So, as I mentioned, this is lesson number 8. We will be discussing models, record managers, and migrations we are using in the Hubleto. So, welcome everyone. On today's agenda, we will have, as usual, a really quick recap what was this previous webinar about. We will discuss what we have talked about recently in past 2 weeks. Then the majority of our today's sessions will be discussions and presentation of our two experts, Richard and Eric, as I mentioned. And after all, we will have also a Q&A session, and we'll be discussing what will be heard and mentioned about next in future webinars. So plenty of work ahead of us. So let's move forward. A great way how to recap is to look at our two major data storages. Sorry. One of is our video archive that you can find at our wai-blue channel at the YouTube. There are all the recordings from previous sessions, and also check our developer's guide at developer.hubleto.eu for more documentation and additional videos and additional codes for examples and live active situations that are in use for this developer guide. So I recommend you really watching the developer's guide for more info about previous and also upcoming sessions. So feel free to check this website. It's really neat and still constantly being updated. Okay, this is a really short introduction from my side. And I believe now it is time to our main speakers to engage. I believe that Eric will be the first that will be joining us today. So Eric, welcome, and feel free to share your thoughts and input about models, record managers, and migrations.
So, hello everyone. Let me just share my screen real quick. I believe it should be live right now. So I would like to welcome everyone to lesson 8 of the Hubleto Developer Academy. Lesson 8 as a whole focuses on models, record managers, and migrations. On my part, I'll focus mainly on records and what the record manager does with them. We'll go through create, read, update, and delete operations. Then we'll take a closer look at saving, because in Hubleto, a save isn't just a one direct database call. It also involves validation, callbacks, and normalization. And after that, we'll look at the records API used by standard tables and forms. We'll also talk about what Hubleto loads together with a record and how relation loading depth works and where a prepared query fits into the entire reading process. So what we'll cover, first we'll begin with CRUD through record manager. CRUD just means create, read, update, delete, the usual stuff. These are the standard database operations, but Hubleto adds its own record layer around them. We'll then follow a save from the submitted data to the database write, including validation, callbacks, and normalization. Next, we'll compare a record save method with calling eloquence on create or update directly. Both options can write data, but they don't go through the exact same process, so they aren't exactly interchangeable, and we'll go into detail into them. Then we'll move to reading. We'll go over the standard records API endpoints and the different pieces of data that can come back with a record. And then we'll finish with relations. In particular, we'll look how Hubleto decides which relations to load, how many levels it should follow, and how prepared query lets us adjust the query before the data is returned. Knut, let's start with the record manager itself. A Hubleto model describes the record. It knows about its columns, relations, and other model settings. The record manager is the part connected to that model that actually works with the data. On here we have 4 CRUD operations. For create, a standard form saves reaches the record save method through the records API. Record save looks at the submitted ID, and if the ID is 0 or lower, it treats the record as a new and sets it through the create path. The actual creation is then handled via record create. For read, the path depends on what we're loading. A forms calls load form data, which applies the form settings, prepares a query for the requested ID, and uses record read to return the first match. A table users then loads table data instead. A table normally needs more than a plain list, right? So this method can add for example, full text search, filters for individual columns, ordering, and stuff like pagination. For update, we again start with record save, but now instead a positive ID makes Hubleto use the update path. So it loads the original record and sends new values through record update. Then the last operation is delete. Record delete loads the record, removes it, and returns the number of deleted rows. Then the API then turns that result into a simple success or a failure status. So although all these methods belong to the same record layer, they don't all do the same job. Record save coordinates between create and update. The load methods then prepare records for different UI contexts, and record delete then handles the actual removal. So let's move on to the record save pipeline. Everything, as I already mentioned, starts with the record ID. An ID of 0 or less means create. A positive ID means update. That's how the save endpoint can handle both a new form and an existing record. Before anything is actually written, though, Hubleto validates the model columns. Required columns must contain a value, and each supplied value is checked by its column type. So, for example, an email, integer, or a decimal number can therefore apply its own validation logic. If this validation fails, the write stops, and Hubleto reports which inputs were invalid. These selected nested records can be validated as well. So relation data isn't actually automatically saved just because it's present. The path must be in the relation saving list. So validation can then continue into the selected either has many or has one records. There are callbacks around validation and separate callbacks for create and update, but we'll get into those in later lessons. On the create path, we have the before create method, which receives the record before the database write. It can return an adjusted version of that record. Then the record is normalized and written. Once the new ID is available, on after create, receives the saved record. So Normalization happens just before the eloquent actually writes anything. Values aren't model columns. Um, Values that are model columns are removed from the database payload. The remaining values are then converted into formats expected by their column types, right? So that's essentially how the normalization works. You can actually configure null values as well. We go into detail on how all of this is done into within our Hubleto Dev Academy lesson 8 on our website. So feel free to check that out. Actually, I would recommend you guys to check that out since there are actually code snippets from actual apps where you can see exactly how this code works. So just to sum it up, on before create can adjust the incoming record, then the database payload is normalized. Eloquent then creates the row, right? So the row is created, and the generated ID is put back into the result. And finally, on after create receives the saved record. So when we call record save, we are starting this entire sequence from the start. We're not just forwarding directly to Eloquent and forcing any action to happen at any point. Next, let's move to record save and its comparison to direct Eloquent writes. So on the left side, you can see we have the record save method, which is the Hubleto standard high-level entry point for form and records API saves. For an ordinary save, it uses the record ID to choose between record create and record update, as I already mentioned. It also starts Hubleto validation and can coordinate selected nested records. The selected create or update method then runs its matching callbacks, which we will get into. Normalizes the write payload and at the end performs the actual write. On the right, we have direct eloquent calls, such as you may be familiar if you guys are used to using Laravel. We have create and update. The standard record manager is actually based on Eloquent ORM. So these methods are available and they do write to the database. But if you call them directly, we sort of enter a lower level and we don't automatically run the complete record save process, which we went through. Direct Eloquent calls can still be intentional and controlled situations. You just need to know which parts of Hubleto lifecycle you're actually skipping. So you're essentially forcing the write. So just to sum it up, because I know the names can also be a little confusing at first, create and update are not the same as Hubleto's record create and record update. They go through completely different stages. For a normal record submitted for a form in Hubleto, record save is therefore the safer default. If you want to use something more direct, it should be because we intentionally want a different behavior or skip a part of the record creation process. Next, let's move into what is actually loaded with the record. So let's switch from writing to reading. So to start, when Hubleto loads a record through the prepare read query, the result usually contains more than raw values stored in one database row. In here, you can see I've divided that response into three groups. The first group is model fields. Hubleto builds the standard selection from the columns described by the model. Normal columns that aren't hidden are selected from the model table. The second group is relation records. If a relation is selected for eager loading and the allowed depth hasn't been reached, its data appears under the relation name that's been configured. So a one-to-one relation appears as a one nested record, and a one-to-many relation appears as a list of multiple nested records. The third group of what's loaded with a record is the record's metadata. So under level, we have the current loading level, and level max is the configured maximum. For one record, the record read method actually adds relations, listing the model's configured relation names, and it prepares IDs for transport. That's why the response used by a Hubleto form isn't quite the same thing as running a raw select for every column, right? If you just use raw SQL, for example, and selected everything for a column, it is a prepared record containing model data and optional relation data, and then even supporting values for the UI. So let's move on to Records API. In here, I've prepared a simple table that summarizes the standard Records API. The first endpoint is the get endpoint. So a form uses it to request one record. The endpoint identifies the model and record ID, and then calls load form data. From there on, the record manager prepares the form query and returns the result through record read, right? So the next endpoint is load stable data. It calls load stable data and supports full text search, column search, ordering, pagination, and the entire requested data view. Then we have a lookup. A lookup is used by to either by lookup or to autocomplete input. So a prepare lookup query method builds the query, and then prepare lookup data turns the loaded rows into options with display values and configure details. Then after that, we have save endpoint. The client actually sends the record and a list of relation paths, which should be saved. So as I mentioned, and the endpoint passes both to record save. So either a non-positive ID follows the create path, while a positive ID then follows the update path. The response includes a success status, so if the save failed or succeeded. And then the final endpoint is the delete. It calls record delete for the requested ID, right? So record delete returns the number of affected rows, and the endpoint returns the ID together with a Boolean deletion status. So you can know if the delete succeeded or if it not. Just to add, these endpoints don't actually replace the record manager or anything. These are here to show you guys the HTTP entry points into the record manager. So the form table or lookup sends a request to the records API, and the API then delegates the actual work to the selected record manager. So now let's look into relation loading and relation loading depth. So in here we explain how much related data Hubleto loads together with a record. There are two separate settings in here, which I want to explain. First, the depth and relation selection. The depth means how far Hubleto should follow relations. So table data uses depth 0 by default, so only the main table records are loaded. Form data uses depth 1 by default, so direct relations can also be included. If we set the depth to 2, Hubleto can go one step further and actually load the relations belonging to those direct relation records. So we should only increase the depth when the screen really needs that extra data which we want to load. Then we have relation selection controls, which relation names may be loaded by. A null list does not actually, by default, restrict the configured relation names. If we provide a list, only the relations named in that list are considered. So these settings do different jobs. The list chooses which relations are allowed, and the dev decides how far the loading can continue. If you guys want to look further into how this is done and actual code examples, I would recommend you check out the Dev Academy lesson 8 page, where you can see actual code snippets from apps and how this may be done and configured to serve your own purposes. So now let's move on to customizing prepared query. So this is the last topic from my side, and we actually use prepared query when a record manager needs to adjust how records are loaded, right? So in here we have two parts. On the left side, you can see why the parent comes first. On the right side is the customization added by the app. So let's start with the parent code. The parent implementation prepares the standard parts of the read. It selects the model fields, adds the joins needed by the lookup columns, and includes the relations allowed by the model settings. If our record manager inherits the ERP behavior, the parent chain may also add the standard visibility filters. So when you guys call parent prepare a read query, first we keep all of the existing behavior. We don't have to rebuild it in every app, and we don't accidentally maybe even remove it. We've went through this in our previous lessons. If you guys remember when we were creating either the currental app or the IP info test app. On the right side is the application level customization. Once the parent has prepared the standard read, the app can only add what it needs. So, for example, it can change the ordering or read an optional request filter and add the matching condition, right? So if you guys remember the filtering from the last lesson. At the end, we return the modified query so that Hubleto can use it to load records. And just to sum it up, the pattern is actually pretty simple. So keep the standard behavior from the parent, and then add app-specific read rules, and at the end, return the result. So that brings us to the end of my part. If you guys have any questions, feel free to write them in the chat, and we'll answer them at the end of this webinar as best as we can. Now I'd like to give word to Marcel back again. Thank you for
Thank you,
listening.
Eric, for your input. So let me quick check the live chat if there is any questions right now. Nothing really pops out, so I believe that Richard will be shortly preparing his presentation. So let's give him a second or two for preparation. And if there are no questions at the moment, we can continue forward with the second part of our today's lesson. So yes, we see your presentation, or we do not see it. So there was a little bit of hijinks. But I believe that Richard will be quickly working it out, and we can see the lesson number 8, Models and Managers and Migrations by Richard. So it's ready, and I hope you are ready as well. So
Okay,
feel free to start.
Hope everyone can hear me on the stream also. Okay, so in the previous lessons, and also what Eric mentioned, there are 3 entities that are used to create. Sorry, just need to adjust something. Okay. Yeah, so let's start again. And in previous lessons, we mentioned that there are 3 entities that are used to create an app. That is the model, the record manager, and a migration. So I would like to briefly describe what each other does. So here they are. A model defines the structure of a table. Most importantly, you define the columns needed for the data for your desired records. You can also create the relations connecting the models between each other. You can also define how the data can be worked with using you can also define how the data can be worked with during or after creating, saving, updating, or deleting a record using callbacks. But that will be mentioned in depth in later lessons. The record manager, as the name suggests, manages all the records of a model. It manages how the data is read and saved. It also defines how the relation data is read and saved. Record managers also allow you to modify how the data is read either in a table or a lookup. You can modify records using record reading through various methods. One of them we mentioned was creating filters and adding them to the prepare read query method. This was, I believe this was discussed in previous lessons. And lastly, migrations. Migrations, simply described, are a SQL schema that runs during a migration process. That can be during installation of an app or just starting the migration process manually. What the migration will usually do is it creates a table in your database, create necessary foreign keys, definitions, and indexes. But the migration can be also for just updating or adding a new column. For a single model, you can have multiple migration files that do these updates. You can say that they are the versions of your tables in the database. You can also downgrade from these versions by defining what will happen during the downgrade by creating the SQL commands yourself inside the migration. So for the rest of the presentation, I will be talking about the actual process of using these migrations. So the most easiest way to create migrations is to use the CLI command available in Hubleto. That's right here on the presentation. So PHP Hubleto create migration. And then we have the app's whole namespace and the model's name to create the migration. As you can see on the right, we have the full model created based on the definition in the model. So the definition of the columns, the foreign keys, or rather the relations between the models, and it also includes indexes. And as I said before, these are based on the definition of in the model, inside the model. So let's get to the actual column definition. Every column class actually has a predefined way of how the column will be added to the migration schema. As you can see on the picture on the right, in the first one, this is basically every definition of the column class we have available in Hubleto. It includes the schema that will be added to the migration when the migration gets created. Indexes are automatically defined for lookups, for lookup class columns, but you can describe some of your own constraints, like this unique constraint for one of the columns. As you can see, the second picture is inside the model, and the last picture is how it looks in the SQL schema. You are not constrained by the model's definition of columns, indexes, and foreign keys. You are free to modify the SQL schema however you want. Just be careful when you do so. In the next lessons, we will be talking about how you can make new versions of migrations to easily upgrade your test or production environment. So please look forward to that. So how do we actually run the migrations? Well, we can run the migrations in multiple ways. One of them is through the installation of an app, either manually or during the installation of your Hubleto instance. When installing an app, you invoke the upgrade schema method defined in the loader of your app, which will install these tables described in the schema. The other method is to use a CLI command, so php hubleto migrate. This will execute the SQL schemas or the commands inside the schemas of all migrations that have not been used or are pending, which we'll also get to in the next lessons. So, and lastly, I would like to mention before going into an example, I would like to mention some common mistakes that may happen during the creation of your models, record managers, and migrations. So the first one is for the relations. You should make sure that you properly define these relations in models, but also in record managers, and also for safety check them in the migrations. So you don't get any errors during testing or during the production. So next one are the controllers. So controllers should not be to filter the data. This is what prepare read query is for in record managers. So like we said before, and like Eric mentioned, we can use them for filtering data, and like in the previous lessons we mentioned that they can filter data using filters defined in other parts of Hubleto. Be wary of the usage of CRUD methods from Eloquent ORM. You should still need that the record manager CRUD methods for validation, normalization, and using the callbacks defined in the models. I would suggest that you remember to change or add a new migration when changing the columns of a model, so that any upgrade or update of your app is properly done. And the last one, permission management is included in the record manager already. So you don't need to manage permissions for every model manually. We will get to these permissions too in the next lessons. So yeah, we will get deeper into this. So last thing is the example of migration creation. In a short example, I will show you how you can update the migration and a table in your development environment. Basically, what I will do is I will add a new column, update the migration, and then update the table using developer tools. So I will change to the car app to the car rental app we use for these lessons. So let me just change to that. Sorry. Just give me a second.
You can have all the seconds you want.
Yes, it's here. So right now we are in the car model. As you can see, I have something ready, but let's check out this car migration. So as you can see, we have only few columns here, like the ID, brand, model, and color, but we want to add one more to this migration. So what we can just simply do is that we can add a new column. For example, we added a purchase date for the car, like this. So yeah, we added the new column class or column type called date, and we also named it. We also added some setters for this column, like so it's defaultly visible in the table, and that it's required to input into a form. So what we can do right now is to use the command that I showed you in the presentation. So we can use this command, php hubleto create migration. Then we added the app's namespace, so it's Hubleto app custom car rental, which I simply copied from up here, from the namespace in the model. And then I added the actual model name, so car model. So, and if we run this command, we should see that the migration has been created successfully. So if we go back to the migration, we can also see that the new column is here. So if we go to the actual Hubleto instance right now, if I change the Hubleto instance right now, just give me a second. Then we should be able to see the column in the form. So let me just change the scene. Here. So right now I opened a new form. As you can see, we can already see the purchase day column inside the form, but we unfortunately cannot use it in this state because it will throw us an error because we didn't actually run the process of adding a new column. So what we can do for at least our development environment, we can use the tools inside our Hubleto instance, our developer tools. We have this quite useful tool called check the database consistency. What this will do is it will go through our models and great, I have an error right now. What it should be doing is that it will go through the whole process of checking the database and the models and compare them if we are missing any columns in the model. So I might have a fix for this. So hold on.
We checked a little bit more of these consistencies or inconsistencies. So give us a little bit of moment to prepare the things.
Okay. Yeah. So right now I was missing one migration from an Hubleto update, so that's why it was showing the error. But as you can see right now, it's showing us the date purchase column, which we can add by running this function. So let's do that right now. So yes, as we can see, it started the transaction which altered the cars table and added the date purchase column. So if we go back, we can just quickly add a new car. I'm just gonna input test into the inputs and see if it works. So if we add like these types of it should add a new car into the system. So as you can see, we already have we created a new record that includes the purchase date also. Okay, so that's it from me. That's it from me. So I leave the word to Marcel again.
Yes, give me a second as well, so I can share the screen once more. Okay, you should probably see it by now. Thank you guys for your input. It was a lot of information to digest, so I give a little bit time to our viewers to think through and gather their thoughts and give us some questions or input or any kind of advice or ideas about these topics. So feel free to check our live chat and write something down. I can see that we have plenty of viewers, so I hope someone from them will have some interesting input, question, or note. In the meantime, I would like to thank my coworkers, of course. Thank you, Eric, and thank you, Richard. And also, I would like to point out that the next lesson we'll be discussing models, record managers, and migrations once more because we have not covered everything that we wanted. So we'll be having a part two in 2 weeks' time. So the date is Wednesday, the 2nd September. So as usual, next session will be in 2 weeks' time exactly at the same time and the same place at our YouTube channel. So feel free to share your ideas about that. Also, as usual, do not forget to check our GitHub for some interesting informations or issues and solving of these issues. And don't forget to check our Reddit, LinkedIn, YouTube, and other channels that we are other social medias that we are available. So you can always catch up with us and discuss anything related to Hubleto and the Hubleto Dev Academy. So feel free to cause any questions because we are in a Q&A session, obviously. So write your questions to the chat and I will get notified and discuss your questions with my colleagues. Feel free to write anything interesting or important or just curious about the things that we have discussed previously in today's session. We have some time left, so we'll wait a little bit more, some 2 or 3 minutes if anything will pop out. So take your time, guys or gals, and we will get back to you in a moment. I just maybe some little bit side note from my side to prolonged waiting. This was a really interesting session for me because I'm not that well versed in the record managers. So for me, it was really interesting to hear all the stuff that we have discussed, and I'm always interested to find new things that I can learn. So I will be there also in the 2 weeks time as a moderator, of course, but also as an avid listener. So hope you guys enjoyed this session so far, and you will be interested in our Dev Academy session also in 2 weeks time. Also, as usual, do not forget to, as I have already mentioned sometime during this hour, but our developer guide is really important stuff for important stuff and important joint information hub. So feel free to check it out. Okay, let me check the live chat. Okay, so far no question. So let's wait a little bit more. Let's give it 1 more minute before we'll be closing this discussion. And if anything interesting will pop out in this time, we will get back to it. But let's just wait a little bit more. Today's session is slightly shorter than usual, but I believe that this format is probably the better than way too long and way too absorbing sessions. So these 45-minute sessions are probably the ideal for this kind of topic. Oh, okay. Unfortunately, we have plenty of viewers, but no questions. So I guess that everyone understood everything perfectly. So thank you guys for great input from your side. So thank you, everyone. Thank you, our listeners and viewers, and hope we'll be seeing each other in 2 weeks' time, as I mentioned. So 2nd September. We will be here, and hopefully you will be there as well. So thank you, Eric. Thank you, Richard. And we'll be seeing each other in 2 weeks' time. See you soon. Goodbye.
Thank you for watching. Goodbye.
Okay.